All right, now let's discuss distinguishable permutations. So distinguishable permutations deals with the situation, what happens if we can't tell all of the items apart? So if I'm doing something like, in this example, you can see if I'm rearranging the letters of the word Mississippi, I can't tell if I have this S or that S. If I was to switch them around, I wouldn't want to count those as entirely different arrangement, an entirely different spelling of the word. Or maybe this S was over there, and this S was there, and this S there. Again, I wouldn't want to count that as a different spelling of the word. These S's are indistinguishable from one another. And what I'm actually trying to count is the number of permutations that are actually distinguishable. How many can I distinguish? So in this case, we're going to start off with a factorial. We're going to say, so n factorial, this is the number of letters in the word. That would be n. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters here. So we would say we're going to start off with 11 factorial. If I could tell the difference between all the letters, between all the various S's and the various I's, I would stop there. I would say there would be 11 factorial ways to arrange this. 11 ways for the first letter, 10 for the second, and so on, until I've put all the letters. But I've overcounted a bunch of these. And so I've overcounted each different way I could have arranged these I's was counted, well, a bunch of different times. And the number of ways I could have arranged the I's, well, there's 4 I's, so there's 4 factorial ways I could have arranged those I's. What I'm going to do is I'm going to go through and in each of these individual groups, I'm going to say how many items are in each of these groups. I'm going to put that number with a factorial in the denominator. Well, there's only one m, so I'm going to say there's 1 factorial there. So there's 1 m. There are 4 i's, there are 4 s's, and there are 2 p's. So I'm going to say there's a 1 factorial because there's only one way to arrange the m's, the m, whatever. There are 4 factorial ways I could have arranged the i's. There's 4 factorial ways I could have arranged the s's, and 2 factorial ways I could have arranged the p's. So by dividing this off, I'm essentially getting rid of a bunch of indistinguishable permutations is technically what I'm doing. I'm getting rid of the indistinguishable ones. And it turns out when we do this, this always will come up with with an integer. If it comes up with something other than an integer, it means you plugged something in incorrectly. So I'll go ahead and plug this into my calculator. 11 factorial divided by, since I'm doing a bunch of stuff in my denominator, I want to make sure I put parentheses around the denominator there. So I'm going to do 4 factorial. Actually, you know what? I'm going to cheat a little bit. 4 factorial, I'm going to figure out separately first so I don't have to type it in multiple times. 4 factorial is 24. So I'll do 11 factorial divided by parentheses 24 times 24 times 2. 2 factorial is just 2. 1 factorial is 1, so I don't need to put it in there. So this is my 4 factorial, that's my 4 factorial, that's my 2 factorial. Overall, I get 34,650 different arrangements of the word Mississippi.